Hey. My name is Naval Virali. I am from System Information Class A 2018, wanted to share a graph theorem, and here I am with my friend gonna tell about the theorem, so please enjoy the content. So Sakti, do you know about graph theorem?
Well, I kinda know about graph a little bit, such as minimum cut and maximum flow.
Oh great, can you tell me about it?
Sure, of course, but first here's I am gonna tell you the definition first. Definitions and statement. The theorem relates two quantities, the maximum flow through a network, and the minimum weight of a cut of the network. To state the theorem, each of these quantities must first be defined. Let n equals v, e be a directed graph, where v denotes the set of vertices and e is the set of edges. Then here's what I know about maximum flow minimum cut and graph theorem. The max flow min cut theorem is a network flow theorem. This theorem states that the maximum flow through any network from a given source to a given sink is exactly the sum of the edge weights that, if removed, would totally disconnect the source from the sink. In other words, for any network graph and a selected source and sink node, the max minus flow from source to sink equals the min cut necessary to separate source from sink. Flow can apply to anything. For instance, it could mean the amount of water that can pass through network pipes. Or, it could mean the amount of data that can pass through a computer network like the internet. Max flow min cut has a variety of applications. In computer science, networks rely heavily on this algorithm. Network reliability, availability, and connectivity use max flow min cut. In mathematics, matching in graphs, such as bipartite matching, uses this same algorithm. In less technical areas, this algorithm can be used in scheduling. For example, airlines use this to decide when to allow planes to leave airports to maximize the flow of flights.
So it's very simple to understand.
Yeah, of course. So what maximum flow minimum cut from your perspective?
Well, a little bit I know is, for any network, the value of the maximum flow is equal to the capacity of the minimum cut.
Alright, you got it, pal.
So there's a little bit of conversation me and my friend know about maximum flow minimum cut and graph theorem. Thank you for watching. Naval Sakti are out. Peace out. For example, if maximum flow minimum cut by graph theorem is, all networks, whether they carry data or water, operate pretty much the same way. The network wants to get some type of object, data or water, from the source to the sink. The amount of that object that can be passed through the network is limited by the smallest connection between disjoint sets of the network. Even if other edges in this network have bigger capacities, those capacities will not be used to their fullest. In the example below, you can think about those networks as networks of water pipes. Each arrow can only allow 3 gallons of water to pass by. So, the network is limited by whatever partition has the lowest potential flow. In other words, there are a few key definitions for this algorithm. First, the network itself is a directed, weighted graph. That is, it is composed of a set of vertices connected by edges. These edges only flow in one direction, because the graph is directed, and each edge also has a maximum flow that it can handle, because the graph is weighted. There are 2 special vertices in this graph, though. The source is where all of the flow is coming from. All edges that touch the source must be leaving the source. And, there's the sink, the vertex where all of the flow is going. Similarly, all edges touching the sink must be going into the sink. A cut is a partitioning of the network, GG, into 2 disjoint sets of vertices. These sets are called SS and TT. SS is the set that includes the source, and TT is the set that includes the sink. The only rule is that the source and the sink cannot be in the same set. A cut has 2 important properties. The first is the cut set, which is the set of edges that starts in SS and ends in TT. The second is the capacity, which is the sum of the weights of the edges in the cut set. Max flow and min cut. 2 very rich algorithmic problems. Cornerstone problems in combinatorial optimization. Beautiful mathematical duality. Non-trivial applications or reductions. Network connectivity. Bipartite matching. Data mining. Open pit mining. Airline scheduling. Image processing. project selection, baseball elimination, network reliability, security of statistical data, distributed computing, egalitarian stable matching, distributed computing, and many, many more. And here are some of example minimum cut given maximum flow. The minimum cut is a partition of the nodes into two groups. Once you find the max flow, the minimum cut can be found by creating the residual graph, and when traversing this residual network from the source to all reachable nodes, these nodes define one part of the partition. Call this partition A. Then here's the problem about minimum cut. In graph theory, a minimum cut or min cut of a graph is a cut, a partition of the vertices of a graph into two disjoint subsets that is minimal in some sense. Variations of the minimum cut problem consider weighted graphs, directed graphs, terminals, and partitioning the vertices into more than two sets. And here's the explanation about maximum flow problem explanation. The maximum flow problem involves finding a feasible flow between a source and a sink in a network that is maximum and not minimum. Explanation. A network can have only one source and one sink in order to find the feasible flow in a weighted connected graph. Well, I guess it's all I know about the maximum flow and minimum cut. Hope it can educate everybody about graph theorem that I just explained. Thank you guys.